In this video we are going to see this expansion, that's a binomial expansion. We will show that the convergence criterion for this for this series to converge is that the absolute value of x should be strictly less than 1. So we have x plus 1 to some power k equals the sum from k equals 0 to n. Let's consider that k is a positive whole number, and k x to the power of n minus k. Okay, let's take Cn to be nk x to the power of n minus k. This is n factorial over k factorial times n minus k factorial times x to the power of n minus k. And now let's find the Cn plus 1. There's going to be n plus 1 factorial over k plus 1 factorial and k factorial, sorry. N plus 1 minus k factorial x to the power of n plus 1 minus k. We want to use the Cauchy test. So we take Cn plus 1 over Cn. That's going to be n plus 1 factorial over k factorial n plus 1 minus k factorial. We divide by Cn, so it's going to be k factorial and minus k factorial over n factorial times x to the power of n plus 1 minus k over x to the power of n minus k. So we can polish that a little bit. It's going to be n plus 1 factorial over k factorial times k factorial n minus k factorial over n factorial x to the power of 1, because we can simplify using power laws. X n plus 1 minus k minus n plus k. So this will go away, this will go away, so it's x to the power of 1. And we can further proceed with the factorials. That one is going to simplify with that one. So here I missed the n plus 1 minus k factorial. So I will have n plus 1 factorial over n factorial times n minus k factorial over n plus 1 minus k factorial times x to the first power. Okay, we can work out this quotient here. Is going to be n plus 1 times n factorial over n factorial, and the other one is going to be n minus k factorial over n minus k factorial times n plus 1 minus k times x to the first power. So this will go away, and then we have the factorials that simplify here. So we have n plus 1 over n plus 1 minus k times x to the first power. Now take the limit as n grows to infinity of Cn plus 1 over Cn in absolute value. That's going to be the limit as n grows to infinity of n plus 1 over n plus 1 minus k times the absolute value of x. So it's going to be x times, in absolute value, times the limit as n goes to infinity of n plus 1 over n plus 1 minus k. Okay, now we take the limit as n goes to plus infinity is going to be So let's manipulate this limit. The maximum, the linear term n to the power of 1, take common factor, is going to be 1 plus 1 over n, and that one is going to be n times 1 plus 1 over n minus k over n. So as n grows to infinity, this will go to 0, this will go to 0, this will go to 0, so the whole thing is going to be going to 1. And you have that the limit of this ratio is going to be x, and by the Cauchy test we know that this should be strictly less than 1 in order to converge. So we have that the absolute value of x should be strictly less than 1. So this is the criterion for convergence. Now, if it's a complex valued function, z plus 1 to the power of n, this can be written as sum from k equals 0 to n factorial over k factorial n minus k factorial z to the power of n minus k, and then we will have c n n factorial over k factorial n minus k factorial z to the power of n minus k. And if we take the limit of cn plus 1 over cn modulus as n grows to infinity, then we have the modulus of z. Z is a complex number now, so this is f of z. This is z belongs to the complex plane, and this should be strictly less than 1, which means that the region of convergence is a circle, is the interior of a circle with a radius 1. So we are centered at the origin of the complex plane. Let's call this omega 1 and this call omega 2. So we have a circle here centered at the origin with radius 1. So the complex, the region of convergence is all the interior points of the circle, of the unit circle with radius 1. And that's for if the function is complex valued. So here the complex, this function is a complex valued function, so it goes from C to C. Okay, and that's for complex numbers is the unit circle, the interior of the unit circle. And that's the end of the video.